uh, presentations for you all today. We have Otto von Zastrow Marx, who's the founder and CEO of Midpage AI, which is using ChatGPT to do provide new services for lawyers. And Mireia Gonzalez is a technical lead at Formal Vindications, which is providing software solutions for the government. And so we're excited to have you. Thank you so much for joining us. We'll have Otto go first, but yeah, if you folks have questions, please use the chat function or unmute yourself. And if you have any updates for the group, any news to report, please put them in the chat. So with that, let me turn it over to Otto. Otto, are you there?
Yes, can you hear me?
Yes, we can hear you. All right, Otto, the floor is yours. You have we have 1 hour for 2 presentations, so that leaves you half an hour for yours. But please, you leave enough time for presentations. So if you could say maybe spend like 10-15 minutes for your presentation and leave the rest for questions, that would be fantastic.
Yes, perfect. Okay. So I will share my screen. So I'll be sharing first a few things, what we do, about how we're going to use ChatGPT, not as Midpage as a company, but everybody to play around. But then we want to also show some quick demos of what we are building, which obviously, building our own technology around these new language models. And yeah, some of that technology is sort of fresh out of the works. So let's hope it all goes well. What we really care about is making the predictions explainable for lawyers. And so this really, so when you've tried ChatGPT, you perhaps have noticed that sometimes it comes up with something that sounds plausible, but you don't know whether it's right, and it's often not. So one thing that I found very interesting to see when we gave GPT some text, there was some context, and asked the question, was there an abuse of discretion? And then the normal version of GPT would say, yes, there was one. And then if you ask it again with the exact same question, it would say, no, there isn't. And then a week ago, when OpenAI released their new model called this ChatGPT Turbo, suddenly this was already a lot better and had sort of this more nuanced answer of, well, actually both is kind of true. They did say yes, but in one say they made an exception. But you still don't know as a user that this stuff is changing so fast. Like, what can I really trust? And so here, what becomes very important is we can make the model, show which part of the source text was relevant for making this decision. And yeah, and so that text was written by humans. We can show a highlight of that text. We can even try and find a snippet that was, within millions of documents that is very relevant and that you can verify by opening the link and so on. And then this becomes a lot easier. And this is sort of one of the key things that Midpage is about. Yeah, and when you look at the source text here, it's kind of easy. So what we build is a writing assistant. Now, since we've all seen ChatGPT, this is also very understandably why we do that. It does no longer make sense to write documents on your own when you can also have a system that does, suggestions and fact checking and adding case references and all those things, where you just give it a prompt and it will write a few lines and then you'll add your own thoughts. And this kind of tandem where sort of both in research and in writing, you can get a lot more effective and a lot more accurate. And so this is the big thing we're building with this explainability. And the same model that language model that you use to build this, and the same retrieval technology that we use to make these explainable suggestions, that is also helpful to build a small question answering system and a citation recommendation system. And those things are really fast to build in comparison. So while this writing assistant is still in the works, we're going to release these smaller things much sooner. And these are also something that I can demo in a small way at least now. Yeah, so first just sticking with auto completion and prompting. Just that you get, some imagination. You've probably all tried something similar in ChatGPT now. But of course, it makes sense to have a model that is, one of these large models trained on lots of legal language. And so what you see here, is that any word while you're writing, you can just add your sort of prompt description of what you want to have, and you'll try and come up with a suggestion that is something that is much easier to verify, or quicker to get to an accurate result than if you have to do the research, open lots of tabs, and then do the whole thing. So sorry for those notifications. Yeah. Now this is.
Can you,
Yeah.
Otto, can you just add a few more words to that? So what are we seeing here exactly in brief writing part here?
Oh, I'm
what
sorry.
is it that you're showing here? So how does it work here? I think you rushed a little bit through this here, but you can write a brief, and then you can just, with this add-on, you can then just do a backslash and then add some terms of art, like promissory estoppel, and then that's when ChatGPT then makes additional proposals for how you can phrase something, and what's happening here.
Yeah, so first what happens is you need to sort of take this whole, it might be a very long document, I need to pass this on to a model that is sitting in the cloud. And also, since these models, they can't have an endless amount of information ingested at once, so we kind of do things to compress that information first. There are like different ways to do that. And yeah, and then it's like when you write out in ChatGPT, that is sort of trained more on this kind of data. So yes, you would write an instruction like you would also something that your associate would also understand, or something that you might scribble down to yourself as a note, that might describe how the next paragraph would look like, and then sort of the model can understand. Sorry, and then the model can understand what you're trying to do. Yeah, does that answer the question?
Yeah, I think, yeah.
Okay. So, and then one step further that is sort of quite important, even though it sounds sort of like a small thing, is that when we have to ask a new system to do something for us, it really requires sort of humans to adopt and learn this new behavior. And one thing that was really interesting in programming, where we have this sort of GitHub Copilot system, is that auto-completion can become much more powerful than you can ever imagine, just from what you remember from Gmail. So in this thing for programmers that is also by OpenAI, this auto-completion is so good at guessing what you're going to write next that it comes up with similar things like this one, just that you don't have to remember to use anything new. And this is sort of a very good training mechanism that sort of enables us to learn to leverage these new systems much quicker than we'd otherwise do. I myself sort of, when I was programming, I used it at the beginning, it was great, but only after I sort of was trained by this thing, by these auto completions, I started understanding what it's really good at. And then I started using much more of these instructions. Yeah, and the same thing is going to happen in law. And then in law, it's sort of important to have these explainable, showing again where the source is coming from, and have the system that is very well trained on these legal data. But this is what we're about. Yeah, but this is sort of more of a thing that we can't reveal anytime in the next 2 months. But one thing that is a lot closer is the citation recommendation. And here I am going to show a quick demo. But just a brief intro on this. So basically, for every argument you make when you're writing a brief, you want to perhaps add some case references, and obviously finding those takes a lot of time. And you're always worried you might miss something. It might be very time consuming to get everything. And the systems are quite good at might need to share my different screen now. At really understanding, learning from millions of how other people made a citation, to sort of understand when and why they cited something else, and then sort of come up with auto-completion suggestions of, okay, here's your argument. Well, here you could add this case reference and this regulation. Yeah, and so let's just quickly see whether I can make this work. So you should be able to see my Word. And so what I basically do here is this. So this can be a very long document, but basically anywhere in this document, I can do this sort of double slash to trigger, hey, add a citation here. And then it would read the text and it would sort of come up with a suggestion. And now with these, I can also see a summary about this case. I can click onto the hyperlink. I get the name of the report and everything. So this now makes it sort of much easier to find something. You still need to verify it as a human, but this is sort of how I really think this will work in the future. And the cool thing is you can actually quite accurately measure, how good these systems are just by giving it a document, removing all the citations, and asking it, can you sort of reconstruct what you would have put here? And I've heard of some people that actually, sometimes do this, that they would give a document to their to their associates and then leave lots of blanks for all the case law to be added there. And then now you get that all at once. And of course, with the summaries, you also get a bit more insight about that. Now I'm going to switch to a different window now. So you should be able to see my browser window. Yes. Okay, and what we have here is just any website. This is court listener, and now you have this very long document. And of course, you might have some questions that are more specific. You might use Control F to search for this, but language models are obviously really good at this too, and that's why we built a question answering system that is going to read the whole document and show you a highlight of the answer. So in this case, this is actually something. This example that I mentioned, something from the law clinic at Stanford. And there was a problem that in Southern California, at these sort of at the borders, if you want to enter the country, there's these detention centers. In some cases, people that wanted support from lawyers were held there too long and didn't get access to the lawyers in time, and so people tried to fix that. And one question that you might have to this document is, okay, did IG, which is just one of these people that had this problem, did he have a lawyer in his second hearing? And now it's going to look through the text and it can automatically find the section here where the answer is contained. The answer is no, but it really makes it easy to get to this. And this wouldn't have been quite as easy with Control F. We can do this on any website that contains legal documents. And yeah, this is sort of something that we think if everything goes well, we might even be able to release that in something like 3 weeks. And we really think, since it is so easy to install and to get going, there's absolutely no requirements. Instead, unlike, you don't need permissions from anybody because it doesn't save anything. And because we want people to use this, we're going to give out the first 100 questions for free. So you can just go to the Chrome Web Store then and install it from there. Yeah, and as I said, this sort of also works in Word. So if I have a long document, I'm just gonna open up the same document in Word, but it works on anyone.
Otto, are you still here? I think
Okay.
all right, so I think we had a little bit of a choppy connection there.
Yes. Okay. I hope that's better now.
It
Then
seems to
I'm
be
just
better,
gonna
yes.
switch to a different screen again, and now you should be able to see my Word again. Yeah, and so here basically, I mean, Word documents can be super long. We will have this problem, and we can ask the same kind of question here. Perhaps let's ask something different this time. I don't know if we look at something that is in here that can be answered from this document. Yeah, okay, so I mean, any question can be answered here, like for example, who is this ID person? So I think actually I might have cut off the document in a way that it doesn't include the answer here. But then it can also tell us that. So I think this is, yeah. So this I think is going to be super helpful. And this is just the beginning. You see sort of rather young software. But I'm going to switch back to the main presentation now. Okay. Yeah. So of course, it's important to know that, you know, does this have all the cases that I care about? And the good thing about these models is that you can train it on 10 million different documents, but then you can evaluate how good it is at different areas. Might be, you know, better at labor law and bankruptcy law than in some other things, but then we can release it in those areas first, so we can like track the performance for those areas. And yeah, and it also makes sort of, yeah. So
Are you available to take questions, or did you want to add some things about the company?
Yeah, just two couple quick things. So we're a startup from Berlin and soon office in New York as well. Obviously looking for some lawyers and, you know, ChatGPT legal prompters to join us, and also to try out our demo. So you can also meet us at Legal Week or sign up to our waiting list. And yeah, so it's very early days for us, but we think with launching this QA extension in a couple of weeks and the citation recommendation in April or May, that's going to be exciting times. And yeah, looking forward to what the rest of the community is building as well. So happy to answer questions now.
Wonderful, thank you, Otto. So is your company solely focused on legal space, or is legal just one of the verticals you're interested in using your tools?
We are only focusing on the legal vertical, starting with the US, at the beginning also focusing more on, you know, litigation and especially briefs, because it just makes a lot of sense to really understand what the data actually means and you know, understand the users a lot. I think there will be some companies that try to build sort of, you know, a model or sort of technology that is vertical, like sector agnostic. But I think in order to become really good at this in the real world, you have to focus on the one thing.
Okay, and so so the main services are now this kind of feature where you can ask specific questions with regard to legal text, and then get ChatGPT to give you answers. Then there's the autocomplete. And what was the other service that you're offering?
And the citation recommendation.
The citation recommendation. Okay. Cool. And so the verification, at the beginning, you talked about the verification aspect, which is very interesting. So where you can help people basically drill down to how ChatGPT came up with a question, what's the source, what's the source of a specific answer, and that's I think that specifically in legal settings is important capability where sometimes the answers, they look very authoritative, the ChatGPT answers, but sometimes they're nonsensical or they're hallucinations, and so that seems like a really important capability. Is that sort of what's your response that you're getting from your early users, if you have any yet?
So I mean, we haven't launched yet. We haven't launched these products yet. So the people that we test this with, it's sort of we show them this and we let them play around with it a bit. And I think the citation recommendation, that seems to be sort of very easy to understand, like why that would be helpful, and to imagine all these scenarios where just going to add things to your text, and if it really proves to be very accurate, and if it makes it so much faster to get to a good case citation, then this is something that they were really excited about. But of course, if you try it out on your own document and it doesn't work, then that's bad. So we have to prove first that it's going to be super accurate, but that is something that we can easily show because it's a numbers thing. We're currently sort of around a 60% overall accuracy, but it means in some areas we're already at 90%, and in other areas we're sort of a lot less. And we're focusing on sort of some areas getting the right first. And yeah, so that is cool. And if we wouldn't have these sort of summarizations and these hyperlinks to show alongside the recommendations, then that wouldn't help at all. And so that's why we care so much about those things.
Got it. Okay. All right, folks. Anyone else has any questions? So let me see what's in the chat. Okay, so Danielle is asking, are you able to dig into some of the techniques that sit under these capabilities? So distinguish between where you're using GPT model, family powered text generation versus web data mining and Q&A powered by other models such as BERT.
Yeah, I mean, it depends on sort of which component you're looking at. The fine-tuning that these large language model providers give you. So if you want to train one of these super large models on your own text, that is not, you're not doing everything from scratch. And for the full text generation, any company doing something like we do is always going to have to build on top of that, but then be very smart about how to do the fine-tuning, which data to put on top, and how to add this retrieval tech. And those are sort of generative language models. If you don't want to go for something like OpenAI, we'd use this Flan UL2 from Google. This is a rather new, like 20 billion parameter model. So it's about 20% of the size. And for the programmers, that has sort of already done wonders. And it can do the same for the real world. But I think when we're doing full text generation, it will always be GPT based. For citation recommendation, because this is a more specific thing, it is going to be our own models that are sort of very specialized for this task. And with retrieval tech, there's sort of a lot of research on how to do this exactly, but basically you have also neural network that is understanding, well, looks through all the paragraphs and kind of understands what they mean, and then sorts them in some list like a library. And then it can, when it gets asked a question, can basically remember, okay, I've read something that was similar, and that's why I sort of pick it out of this library, and then I've only answered the question after I've done this. And how to do this exactly, that can get quite technical, but those are also all of these language transformers.
Mm-hmm. Jason's saying, with regard to explainability, isn't this less AI explaining its own answers, but more using AI to do the information retrieval of the text that could be pertinent to a response?
Yes, that's a great point. I mean, you probably wouldn't notice right away if you were just using it, but if you're sort of understanding how these systems actually work, if you give it some text and you tell it to like use this text to answer some question, it might not always use that. But sort of we've got good enough at creating a sort of feedback loop around that process. You can just, do simple checks to see whether it's actually relying on that information. You can use both. In theory, you can also use the attention mechanism behind that, like the more technical way. But you can also just ask it with questions. Hey, did you use the text that was provided here? And we can sort of scale this up and just do testing on whether they correlate. And over time, it will become very important to sort of when users accept things, also like bring that whole feedback loop back into the model. But for now, it seems to work surprisingly good just by doing that kind of prompt engineering and fine tuning around that.
Cool. Dietrich is saying if you have a perspective on other models besides ChatGPT, some of them you mentioned at the beginning, but can you comment on whether other models are as good or better than ChatGPT for certain tasks?
I'm sure for certain tasks you'd find something, but I think the main advantage of other models is that you get a better API for fine tuning.
For which models is that?
Well, the open source ones are the best ones to really sort of decide what you want to do with them, because you can actually train them. But what happens with GPT when you train it is you're just training a tiny slice of it because it's too expensive for OpenAI to do the full thing. And there's some other providers like Cohere and also some Aleph Alpha ones that try to give like similar scale models but give you much more control. But this sort of market is changing quite quickly. So whatever trade-off is good now might not be the right trade-off 6 months down the line.
Cool. Thank you. Well, very cool. And so how did you, so are law firms indeed your target market in legal, or are there other players in the legal industry that you think might be better targets?
Yeah. I mean, yes, this is obviously all meant directly for lawyers, for the users. And I think the best way to get adoption with these kinds of systems is to reach those that are eager to try out things, those that are currently already playing with ChatGPT, that sort of want to, benefit from those new tools. There might be more tech-savvy individuals among the legal scene. So we're going to try and target those individuals first, and not, try and do sort of a slow classical sales process. I think everybody will have to adapt a lot faster in the future than they have in the past, and that's why we're going to take the way that to go with small companies and individual users first. Even if you're in a big company, you can use it, but you don't have to wait until your admin sets this whole system up. This is what we're going to try and achieve.
Cool, awesome. Well, good luck with your company, and thank you so much for telling us what you do. It's such an exciting topic at the moment, and please keep us posted. I would perhaps encourage you to put your email address into the chat so that folks can reach out to you directly if they have more questions. And,
absolutely.
Yeah. Sorry, did you say something?
Yeah, no, also thanks a lot from my side. I do recognize some names. The legal tech scene is not huge, so that's fun. I'm looking forward to the next presentation then. Yeah, thanks.
Legal tech scene is huge, I think. But
yeah,
good to have you, and yeah, hopefully we'll see you again soon. And yeah, let's turn it over to Mireia now.
okay.
Thank you, Otto. Take care. Good night. I know it's already late so over there. Thank you so much.
Thanks.
All right, Mireia, over to you.
Good afternoon. Can you hear me well?
Yes, we can.
Perfect. Let me then share my screen. Okay, I guess you are seeing my screen now. Okay, so today I'm going to speak about our main contribution to this field. I'm going to speak on behalf of Formal Vindications. This is joint work with all my team, of course, and especially with Guillermo Resil, the CEO of the company. and we are presenting public certification as our main contribution, and we want to provide context on why it's necessary for computable laws, or what it's also called, as we've seen, computational laws. So first, let me define what we understand by computable laws. These are laws created with the aim to be technical specifications for designing software and automations of processes through software. So in our case, we were working in the road transportation sector, in particular with computable laws for the hours of service of drivers. There are laws of this kind in Europe, in the US, and also in Canada, and in basically all countries in the world. So these laws regulate the hours of service of the drivers. They regulate how much time they drive, how much time they rest, and so on. Trucks have these devices inside. They are called ELDs in the US, electronic logging device. And this device registers the activities of the driver. Then the police can check the data of the device to see if the driver has complied with the regulation. And that's the software that we were verifying in the first place. So what we encountered in this context is that regulations that are meant to become software are flawed. And to illustrate this point, we have chosen an example that is very simple. It's not from this particular laws. It's a very simple example that conveys what are the difficulties that we encounter. So this is a quote from a bill in Kansas that fortunately failed to pass, but it went through several revisions before someone noticed that this was a problem. It says, when two trains approach a crossing, both shall stop and neither shall go ahead until the other had passed by. So let's imagine for a second that this would need to be implemented for a traffic light system. So software engineers would receive this regulation, and they would, of course, notice that something is wrong, and then they would have to make a decision between three options. The first option is follow the law, but of course this is not operationally desirable because then the trains stop forever. So there's a second option, which is the one that they usually take, which is a self-correct. In this case, it could be prioritizing one of the trains arbitrarily, just choosing how the traffic lights prioritize the trains. Of course, the problem of this is that it breaks the law. And this means that legal decisions are being made by software engineers instead of being made in the channels that the government has for this. So there's also a third option, which is tackling the root of the problem, which we're going to explore today. But first, let me remark that if any code that supposedly follows one of these incomplete or inconsistent computable laws gives a final result, then in 100% of the cases, the engineer took the self-correct path, because it's the only way an incomplete computable law can give results in all cases. So this takes us to what we believe are the highest level issues nowadays in computer science. These are two questions that have uncertain answers and that are going to orient our talk today. The first question is, can we prove that the code is exactly as the specification, in our case, the computable law, prescribes? And the second is, can we prove that the specification, in our case again, the computable law, is mathematically consistent and computable? So if we can not prove it, then the software engineers become the real lawmakers. They make the decisions that mark this software, and because of the uncertain answer that these questions have in the real world, rockets explode, AIs run out of control, and in the case of computable laws, it's even worse because this has consequences for civil rights. There are drivers that are being fined or going to jail because of this. And to put an example, let me show an article that is being enforced in Europe, being inconsistent. It says, after a driving period of 4.5 hours, a driver shall take an uninterrupted break of not less than 45 minutes unless he takes a rest period. So far, so good. But the second part says, this break may be replaced by a break of at least 15 minutes, followed by a break of at least 30 minutes, each distributed over the period in such a way as to comply with the provisions of the first paragraph. The issue is that you cannot comply with the provisions of the first paragraph following the second one because they are mutually exclusive. And this might seem silly, but in practice, this is enforced by many different versions of software. And in each case, a software engineer made a decision on how to enforce this. And these are different decisions that are arbitrary and are meaning fines for drivers. So in what we first tried to bring to this world was formal verification for the law field. And in this case, let me explain a bit how we work. What we have is, on the one hand, the code or the implementation, which is this black box. This is what every software has. It's a code that expresses operations that are meant to be efficient and to be followed by computers. So this is basically the program. But then, if you want to formally verify it, you need a formal specification written in a formal language. A formal specification basically says what the software should do in an abstract and conceptual way, while the code says the steps to do it. So once you have both things, you can provide a mathematical proof, computer checked, that both coincide so that the code behaves exactly as the formal specification says it should. We do this in the CodeX proof assistant, which is a theorem prover, a mathematical system that allows us to formalize all of these steps, including the proof. So after this, we are 100% sure that the code corresponds to a formal specification. That should be it, right? End of story. But it happens that we find a problem to this method in this world. Basically, the issue is that the designers of the formal specification, which in our case would be the legislators that write laws, they can't write a formal specification in formal language because they are not mathematically trained. And the users, which would be the enforcement agencies, the citizens that have to follow this law, they can't read a formal specification, again, because they are not mathematically trained. Even experts go through intermediate steps to understand a formal spec. In the words of our CEO, what can be understood cannot be proven, what can be proven cannot be understood. So how do we solve this issue? Basically, our solution is to include another step, which is called interpretation or technical specification. And this is a translation of the formal specification into different descriptive levels of language that are closer and closer to natural language. So yet it again expresses what the software does, but in this case, it's more accessible, it's closer to natural language. Of course, we cannot prove mathematically that there's a correspondence between the formal specification and the technical specification because you cannot prove things in natural language. That's the main issue. But we can have human experts check this translation and narrow the gap considerably, the gap between these two worlds, between the user and what the code actually does. So that's what we call public certification of a specification and its software. Public certification then goes beyond formal verification in that it allows to be checked by anyone as far as they reach enough knowledge to check all the steps. So we were developing this in the context of working, for example, with the US 395 Hours of Service Act, where this issue is crucial because there are 300 ELD providers So this means 300 different versions of the software running at the same time. In particular, this issue is expressed through the way this software deals with time, and I'm going to speak a bit more about time because it marked our agenda quite a bit. So basically, laws usually require that time is managed in UTC. All these hours of service laws require UTC. So, okay, at the beginning for us, this was just a matter of let's just use any time manager that deals with time in UTC. What does this mean? So basically, when you deal with time in software, you need to be able to translate from the datetime format, which is the one we usually use and understand, and the one that computers use and understand, which is the timestamp. A timestamp is just the number of seconds elapsed since a chosen origin, in our case 1970. So basically you need this little software that can translate between the two formats. Since UTC is usually required everywhere, we thought that any of the commercial time managers would do. And reading the documentation, they usually claim to be in UTC. But what we found out is that actually Microsoft, although it claims to be in UTC, is not in UTC because they don't take into account leap seconds, which are a part of the standard. Then the same goes for Apple, Android, Linux, and we even tried with ChatGPT. And it turns out that ChatGPT is unable to give an answer in UTC because it relies on the wrong libraries. It relies on the operating system libraries. And what's more, it's even unable to notice that it's not in UTC. So it is convinced that its answer is in UTC, but it's not. And that shows, as Otto was saying, the problems that using and trusting too much this artificial intelligence would bring to a critical system like the law field. Especially if we do it in these unreasonable ways. So the only thing we could do was to develop our own time manager, which of course it's in UTC, and it's the first project that we did under this method of public certification. It's available to try and test in our webpage, and it's open source. So our current and future work to be released soon is the whole worldwide transportation regulations for the hours of service combined with this time manager that we developed. And we are also verifying the SHA 256 algorithm, which the three of them combined would give us tamper-proof results in the sense that this SHA can avoid manipulation of evidence. And with all of this, we consider that we have the first ever formally verified AI, where AI should be understood, in our opinion, as something wider than this modern sense of only machine learning. We should recover other historical senses of AI, where AI could be under control. Because in critical systems, like, for example, the law field, we really need that AI is under human control. That's our take on this matter. So that's it. We'd like to collaborate with any of you. It's been a pleasure to speak in CodeX. Of course, if you find any computable law, we can do its public certification. And I'll be happy to answer any questions you may have.
Thank you, Mireia. Great. So, yes, there's a lot going on, and I have to say at CodeX, we use, what is now more and more referred to as knowledge representation. It's a good old-fashioned AI to do things like representing contracts, specifically insurance contracts, in computable form. And that question that you alluded to before, how do you make sure that computable, the formal version of the contract, is actually the same as the natural language version, is a question that comes up frequently. And So you've been working on the same issue, but in a different use case, and and so how does the I'm not quite sure understood though how do so how this public certification works then. So does that entail like a panel of experts who will then say, well, yes, this code here actually is a one-on-one translation of the legal code in computable form, or how does that work? Sorry, I got a little lost there in your presentation.
Okay, yeah, so basically it depends a bit on how we decide to write legal text, because if legal text is written in natural language, then the origin is one, and if in some use cases the law is written in a more technical language, then we can start from there. But in any case, yeah, our take is that there's a panel of experts that translate between the formal language and the natural language. Of course, there's another or the same panel of experts that prove that the code is correct. That's a whole topic. But then this translation is documented in such a way that anyone can check, that is, any other panel of experts could check that this makes sense. So it's kind of make the certification public so that everyone can check that this makes sense.
So yeah, so this is also yeah, if you give the tools to the domain experts, right, to you say it's the lawmakers or it's the lawyers who are creating a contract, so that they can create the contract from the get-go, or the law from the get-go, in a way that computers can reason with, and that is a computable representation, and that's still understandable to the domain expert or even the layperson, then you can do what we call correct on capture. You capture the logic of a law in a form that's computable, and it's authored in that way. And but okay, so I get that point. And then obviously when we go from sort of the legacy approach of natural, we're starting from a source of natural language, then we still have that kind of translation verification challenge. Good. All right, this is great. So let's see what are there any questions in the chat? One second. Oh, okay. So Jason's saying that he's working with the government of Canada on blocks, which is designed to allow non-programs to create a validated, executable, but still natural language specification of a law using goal-directed constraint answer set programming. I wonder if that could be used in the first phase of making laws computable in your process. And so his question is whether people in the public sector are demanding formal verification. Most people he deals with in a public service don't even necessarily know what formal verification is.
Okay, so to the first question, that's very interesting. I've been in contact with other people doing similar things, and I believe it's a bit more limited in the context in which it can be used, because this kind of programming usually is not very expressive. So in our case, it's so in the road transportation sector, the law is quite complicated, so it's algorithmically a challenge. But this would be very interesting to explore if you wish to take the conversation further. And regarding the public sector and whether they know what formal verification is, I wouldn't say that they are demanding formal verification explicitly, but and they actually don't even know what it is. But what we encounter is that their problems could be solved in this way. So they are looking for help with problems that they don't know can be solved through formal verification, but our answer is that they could.
Guillermo is saying, from the original document to the final verified specification, there will always be changes if you want the total guarantee and proofs.
Yeah, so Guillermo is the CEO, so he's talking about our own method. Yeah, what he means is that from the document that, for example, the legislators give you, until you reach a formal specification, you probably have to make changes because the original document can have inconsistencies or something that is incomplete. Or so actually the whole point of this process is that you can find that the regulation is flawed.
And okay, so you can find inconsistencies and things like that. So this law, I forget which one it is, with regard to the the time, like truck drivers are allowed to drive. The what's the law called again?
The hours of service of drivers.
Yeah, oh yeah. So is that sort of like your entry point into this space of like using formal verification in sort of legal settings, and you're now looking into other areas where this can be used, or is this your main use case?
Yeah, totally. So the company started because some people had experience with this regulation and finding problems in this regulation and also in the equivalent one in Europe. But yeah, now we are moving into other sectors because we think this method can be applied to any sector that has critical systems.
Okay. And what's your thinking about, like, once you have this in computable form, then what's your thinking about making it also enforceable? Once you have it, you could think of systems that then basically stop a truck on the road. What's the political take on that? I assume that would be not very popular. Yeah. Do you have any thoughts on that?
Yeah, so usually people trained in law would talk about jurisdiction, and they will say that this is crazy. And I agree. I think there should be room for exception. There should be room for a judge to evaluate the context of a particular case and so on. But the main point is that if we are going to use software and we're using it, it should be clear what this software is doing, and then a judge can evaluate something against what the software said. But the thing is that this judge, to have all the material, should know exactly what the software is doing, and that's our only take. We're not going further with machine-like politics.
Yeah. So I was sort of questions here. How do you do that at scale? So it's one of the things we're thinking is when we turn insurance contracts and make them computable, you can automate many different processes. You can create new services and applications that operate on top of those computable contracts. And I wonder, you can create great efficiencies and capture a lot of interactions, and you have a working system. But the question is, do you have to do ex ante, make sure that, like, the system is completely faithful to the underlying contract, or is it okay to just wait until there's like a breakdown and somebody is not happy, and then you have a way to sort of expose, to have a judge that might be aided by experts in the field to see why there was a breakdown and there's a case now. And so I don't know, do you have any thoughts on that?
So I don't know how this applies to the contract context, but in our context, it's already the case that people are not happy with how it's working. So I
Okay.
think the solution is very much needed.
Okay, got it. Okay, so so here's a question. Okay, so there's like okay, so yeah, Luciana is saying that there's a big train collision in Brazil, and your solution would already made a difference there. And yeah, others are, I think, just saying that they really enjoyed your presentation, and then asking you to connect. And yeah, so this is great. We're pretty much at the end of our time, but the two great presentations today, and yeah, what Karam's asking where they can find an example specification. Can you give example for?
You can try in our webpage formalv.com, but I also could send some slides that are prepared for other topics that give examples. So Karam, if you want to give me your email, I can send you something.
All right. Excellent. So yeah, wonderful. Great session again today. Let me see. So I have one more question. So is your target audience at the moment is sort of public administration and lawmakers that are promulgating rules and that need to be turned into computable systems, so that's really your target customer base?
Yeah, that's our main target in the legal field. We are also talking with the aerospace industry and things like this, but for the legal field, yes, public administration is our target.
Great. And you guys are located in Barcelona, Spain?
Yes.
All right. Good. Well, thank you also to you for staying up so late and sharing your story, and two great presentations today. On behalf of everyone, a quick round of applause, and yeah, we'll close here. I don't know if we have another session lined up for next week. Megan, do we have anything lined up for next week?
Not for next week.
Not for next week. Okay, so but stay tuned. We'll send out an announcement as soon as we know who's coming in. And yes, so Megan kindly shared the link to Future Law, which of course is our big conference on April 13th. There will be adjacent events that might also be of interest. So check it out on the website. And we hope to see many of you here on the Stanford campus for that. And yeah, good to see you all today. And yeah, see you again next time. Thank you very much. All right, and thank you to our speakers again.